So when we work with binomials that contain radicals, we're going to do a lot of the same stuff. Now, I just want to let you know we're only doing example 1 and 2 today, so don't be freaked out when I don't do example 3. Example 1 gives you a binomial, but instead of having normal variables and numbers, you have radicals, numbers, or a combination thereof. Got to make sure I copy it right. You guys know I'm good at copying stuff wrong. Okay, so example 1 says simplify. So this is A. Okay, now it doesn't fit this pattern or this pattern, the perfect square pattern or the difference of squares pattern. The reason I know that is because this and this are not the same thing, nor are these. They have the same radicand, but not the same number preceding it. So we're going to FOIL it, okay? And I'm going to use the old terminology here to try and bring you back to that thinking process. The product of F is 12. The product of O, 4 times 2 radical 7, 4 times 2 radical 7 is going to be 8 radical 7. 4 times 2 radical 7 is going to be 8 radical 7. I, 3 times radical 7 is 3 times radical 7. And L, lost my place, 2 radical 7 times radical 7. So the end result of L is 2 radical 49. Would you agree with me? 2 radical 49? But 2 radical 49 is obviously 2 times 7. Okay? So I'm just kind of showing you that step. You might not even do it. You might right away do it in your head. That's what I would do. Okay. The 8 radical 7 and the 3 radical 7 get combined, giving us 11. And you bring down your 12. Finally, combine your 12 and your 14. And you should end up with 16 plus 11 radical 7. Try 26 plus 11 radical 7. Okay? All right, that's A. Now B is where we're going to see a pattern. We're going to see a difference of squares, or we're going to see a perfect square pattern. We're going to be able to square what we're given. So 2 radical 3 minus radical 6 is being squared. So when you square a binomial, identifying each position, this is the A and this is the B. Sorry about that. The result, using that as identifiers for the location, is A squared minus double the product of A and B plus B squared. Okay, that's going to be the end result. So, 2 squared is 4. Radical 3 squared is radical 9. So, 4 radical 9. Let's simplify that, shall we? Okay, that's going to be a 12. Okay, double the product of A and B. So the product of A and B is going to be negative 2 radical 18. Negative 2 radical 18, which I just factored to 9 and 2 because I'm going to pull out the square root of 9, which is 3, and multiply it by the 2. So 6 radical 2 is twice the product of A and B. 3 times 2. 4 times 3. Sorry, I didn't double it. Forgive me. So, twice the product of A and B. 2 times 1 is 2, double it 4. Okay? 12 radical 2. Last one. Radical 6 squared is going to be positive radical 36, which is a positive 6. Okay? 18 minus 12 radical 2 is your final answer there. Okay? This 2AB part, double the product of A and B, 2 times radical 18 doubled 4 times radical 18, which I factored. 3 times 4 is 12. That's how I got that out of there. Okay? So this one was the squaring of a binomial, and that is the result. So using that pattern, we ended up with this. Now, if you don't like that, you can also take it and write it twice. 2 radical 3 minus radical 6 multiplied by 2 radical 3 minus radical 6 and FOIL it. Okay? FOIL and combine like terms. I don't care how you do it. I just happen to prefer doing things quickly and using a pattern. Now C. C is the interesting one. C is A plus B pattern times A minus B pattern. So A plus B, A minus B. The reason I'm saying that is because what exists in the A position in both spots is the same, and what exists in the B position in both spots is the same. It looks like this. 4 radical 5 plus 3 radical 2, 4 radical 5 minus 3 radical 2. Okay? Now you can FOIL this, F-O-I-L, but O and I are going to cancel each other out because the O is negative and the I is positive, but the exact same product. Okay? And then L. All right? So if you just think of it as this, you end up with 16 radical 25, and I know that's a 5, and we're going to take care of that in a minute, minus 9 radical 4, and I know that's a 2, and that's going to come out, okay? 16 times 5, which is the square root, is 80. 9 times 2, which is the square root, is 18. And you should have ended up with 62. This is one of my favorite ones because the result when you multiply opposites is an integer. Okay? The result when you multiply opposites is an integer. Okay? Let's scroll down a little bit right below example C where they introduce a term and it is called the conjugate. Okay. The term conjugates describes an expression that looks like this. Say A radical B plus whatever radical D times A radical B minus C radical D. Ran out of room. In other words, two different things, A plus B, A minus B. Okay? 2 different signs. Now, what this does in a conjugate is going to create an integer every time. Okay? So if you multiply anything that looks like this, okay, translated into into radicals, looks like this, something radical plus something radical, same radical minus same radical. Okay, the A position matches, the B position matches, separated by opposite signs. Okay, whenever you have this situation and you're told to simplify it, the end result is going to be a number. Okay, the end result is going to be a number. Now this is going to come in handy for us as we actually start using all this stuff to help us with to help us with new numbers. Okay, example 2. This is the last thing I'm going to show you. I do have a couple of these though real quick. So example 2, 3 plus radical 5 divided by 3 minus radical 5. You're saying to yourself, okay, well it looks like the 3's would cancel. I don't know, is it -1? No, don't think that way. Because remember the square root of 5 is going to be some weird number. In any case, what you have to do in order to solve this is get the rationalize the denominator. And to rationalize the denominator, somehow you have to eliminate the radical. Now, lucky for us, we now know about conjugates. And utilizing a conjugate creates an integer when you're dealing with a binomial-looking thing. 3 plus radical 5. 3 plus radical 5. If I multiply both the numerator and the denominator by the conjugate, okay, here's our use of the conjugate, the end result is going to be 3 times 3 is 9, minus the square root of 25, which is 5, okay, which obviously is going to be 4 in the denominator. You guys see all that? That's obviously going to be 4 in the denominator. But the top is basically like squaring, isn't it? A squared plus twice the product of A and B plus B squared. Or you can FOIL it. I'm going to do the A squared method. A squared is 9. The product of A and B is 3 radical 5. Double it, 6 radical 5. And A squared, twice the product of A and B, B squared, radical 25. Okay? So on the top, I have 14 plus 6, radical 5 over 4. Okay? 14 plus 6 radical 5 over 4. You might be thinking, well, can we reduce anywhere? You bet we can. The 14 added to can be reduced that way. Okay? This can reduce on both places. You might think, well, if this reduces this, it can't also reduce that. No, it can. This can be separated this way so you can visualize that this becomes 7, that becomes a 3, and both times that created a 2 in the denominator. So you can combine them all and make them all over 2. Okay? When you have this, you're almost there, but you have to look for a way to reduce if you can, and then go from there, and that's your final answer. Let's do one more, example 2, which is a situation where you have a binomial-looking thing in the denominator, and we're going to get rid of it. 5 plus radical 2 divided by radical 5 minus radical 2, multiply by the conjugate, radical 5 plus radical 2, radical 5 plus radical 2. Okay, in the denominator, that creates 5 minus 4. Wait, 25, square root of 25. 25 minus square root of 4, which is going to be 5 minus 4. So that's a 1. Did I write something wrong? I'm coming up with something different from them. Say again? Square root of 2. Thank you. Like, what am I writing wrong? Thank you. 5 minus 2, dummy. Okay, not 5 minus 4. Okay, so A squared is going to be radical 25, which of course we're going to fix. The product of A and B is radical 10, so plus 2 of those, we doubled it. And B squared, radical 4. So 5 and 2, 2 radical 10. This is the numerator. 7 plus 2 radical 10, all of that over 3. Can it simplify? 7 and 3, no. 2 and 3, no. That's your final answer. Okay? Conjugates are super, super easy, and it is going to come so in handy for you. You're going to use it for the next several lessons. Today you're only doing odd.